Point here, we're going to do some notes. Again, entirely up to you how you want to handle this. If you want to wait and just print them out, the PDF at home off Schoology, that's fine. If you want to jot some things down, you can. If you want to just sit back and watch, you do what's best for you. Don't get pressured by your neighbor. Okay. So, distance. We've already talked about this already. Distance is how far something moves with no regard to direction, whether you go forward and back, it's total distance. There's no positive or negatives. Okay? And when you're talking distance, the rate of motion is called speed. And here's an example. On a bike, you travel 6 meters in 1 second, 12 meters in 2 seconds, 18 meters in 3 seconds. So what is my speed? I think, yeah, you can type in your answer. Where is the response? Start assessment. Right? What's the speed?
Oh. Not everybody's done.
Yeah, I'm waiting. Come on, you guys. Type in your answer. How fast is this bike going? Just a number. And of course, yeah, what's the answer? 6. 5. Correct answer is 6, right? We're going 6 meters in 1 second, 12 meters in 2 seconds, 18 meters in 3 seconds. 6 divided by 1, or 12 divided by 2, or 18 divided by 3, right? Nod, yeah, I get that. I see a few. Continuing on. Okay, so now what's displacement? Displacement is the change of position in a particular direction and is always a straight line segment from one point to another. And you've seen this many, many times. Delta D is xf minus xi. That is a formula you're going to need. Final position minus initial position. We know that displacements or vector quantities can be combined in a vector fashion. What do I mean by that? It means you can add them, tip the tail, or subtract them, as I've shown you, right? Remembering that velocity is speed in a particular direction, making velocity a vector quantity. Mr. Bent, you repeat yourself a lot, right?
No.
There's a reason for it. Any questions about any of that? So, distance. How far you go without regard for direction, displacement, really is the difference between where you were and where you are, and worried about direction. And velocity, speed goes with distance, velocity goes with displacement, right? Okay, so a position time graph will also show speed or velocity, right? Generally, don't get hung up on the difference between speed and velocity. For the most part, they are interchangeable. Very rare instances, there is one on the Ladybug assignment, where I have to get you to know the difference between speed and velocity. Okay? Give me 30 seconds. This graph shows 3 objects moving at a constant velocity. Jake, how do I know that they're constant velocity?
The lines are linear. Straight.
That's a big word. Let's say straight. Yeah, straight lines, right? Lines are straight. The lines are linear, hence the name. The velocity remains the same over the entire displacement. The result is a straight line graph. So what I want you to do is, now this is that graph right there, right? You've got it. I need you to figure out the slope of A, the slope of B, and the slope of C, and I think I have to do each one individually. Okay, so go ahead and do slope A. It's question number 2. While I talk to Mr. Thacker here for a second. Okay, so you want to find the slope of A. You should be able to look at it and see. I've sort of given you rise over run here a little bit, right? It goes up how much?
3.
Goes up 3 and over 1. So what's the slope of A? 3. Now, 3 meters per second. In fact, you could say it would be like 6 minus 3, right? 6 minus 3 over 2 minus 1. Anybody out there in physics land never heard the word slope before? Anybody never calculated slope before? Good. So, it is in fact a constant 3 meters per second, right? It stays 3 meters per second the entire time. There's no speeding up, there's no slowing down, it's 3 meters per second the whole time. What's the slope of B? Yeah, the slope is 1. Okay, so it's going to be 4 minus 2, right? 4 minus 2 all over.
Excuse the interruption. This will be the
2.
final and last call for pictures today. So if you have not had your picture taken, please go to the multi and do so immediately. And that includes staff. Thank you.
1 meter per second. Now you'll notice this one, the A value was 3, the B one is 1. Which one is steeper? A. The bigger the number, the steeper the slope, right? Hopefully you're ready for slope C. Now, slope C I have to do in fraction form. You have to enter something and then the slash, the divide, something else. You can get it in fraction form. This one, we might get a few people get it wrong, but because of technical issues, right? Yay, correct answer? 1 over 3. How did we get that? Here's the rise over run. It's going to be 2 minus 1 all over the run here. 6 minus 3, 1 over 3, or a third meter, 1/3 of a meter per second. Okay, easy stuff. Here's one more thing. I've already given you a hint to this one. The bigger the slope value, the steeper, the flatter, the thicker, or no difference the line. The bigger the slope value. Correct. Okay, these have all been examples of what we call constant velocity, right? Since the velocity is constant, the velocity between A and B is the same as the average. Now, if I talk about the whole average, Steve DeRoche, I'm talking about the slope of that line. So it would be like, this would be the average here, right? They've got these backwards probably. The average velocity is going to be, see, I end up at 6, I started at 1, 6 minus 1, divide my time, 10 minus 0, my average velocity is 0.5. The velocity between points A and B, which I'll draw in a darker color here, between A and B, how much is the displacement? It goes from 3 to 4, so 4 minus 3, and it takes from 4 to 6 seconds to, why are those numbers the same? Because the line is
Linear or
straight. The line is straight, and constant velocity is a straight line. He keeps repeating himself, hoping that you'll all get 100%.
I didn't.
Right? The velocity is constant, so that means that the average velocity is the same as, in fact, I could pick any 2 points on that graph, and you would always get a slope of what? 0.5. How come? It's a straight line. How come? Constant velocity. All means the same thing. All means the same. Now, regrettably, most trips do not happen at a constant velocity. You have to speed up. You have to slow down. You might have to pass slowpoke drivers like myself. Right? Trips are not straight lines. Okay? So, for example, here, you can see it sort of does what right here at the start?
Just getting out of the city.
Yeah, it sort of curls up, right? It starts off at 0. In fact, it's not quite 0. It'd be like, have to flat to be 0, right? But we're going to say it starts off at 0, speeding up to about 3 seconds, right? It's about here where it starts to straighten out. So I would call that interval A. During interval B, it moves with a constant speed because the line right here is straight. And then it slows down during interval C. How can I tell that it's slowing down right here? Yeah, it starts to flatten off, right? If it stopped, then it would be completely flat. What do you think we call this from the crossword puzzle? How about variable velocity? What does the word variable mean? Changing. Variable means changing. This is variable velocity. It changes. Now, is the average speed going to be the same as individual speeds?
No.
No, because why? The change in speed, the speed is changing, the velocity is changing. It's variable. Exactly. Am I going too fast? Give me a nod if I'm going. Say, you're going too fast. Instantaneous velocity is a word you need to know. Is the slope of the curve at a single point or instant. Okay? It is the slope at an instant. To determine this, you need to find the slope of the line that is tangent to the curve. In other words, a line that just touches the curve, and we say approximates the slope of the curve. Okay? Like, for example, if I were to, just watch for a second, I'll give you a chance to copy down, right? If I were to zoom in on this curve right here, let's just go zoom in here. View, let's just zoom in to like 200%, right? And then let's zoom in some more. 300%, right? And if I'm talking about a certain point right here, as I zoom in, that little bit of the line, like if I could sort of do this, if I could draw a box around that, and I would just to recreate that, right, in the bigger format, eventually, drawing a box around it, right, eventually what? The line becomes straight. Like I've zoomed in, instead of like 1, 2, I'm between 1.1 and 1.2. I've zoomed in on the line. The curved line sort of does what? Straightens out. Okay? This is an important concept in calculus. Very important concept, and someone much nerdier than me will have to explain that to you. I could, but not at this point. Okay? So, and then what you do is you take that tangent line, and you extend it. And why do we extend it? So that we can find 2 points and then find the slope. So really what you're doing is you're trying to find the slope of that curvy line at that point by drawing a little teeny tiny line that's the same slope as that, and then making it bigger so you can find it. And that really is kind of a main idea behind calculus. And a guy with a tie is going to have to explain it to you. I'm not qualified, I don't have a tie. I actually could teach you calculus if I wanted to. If you wanted me to, actually. Not if I wanted to.
It could be one day just for fun.
Teach some calculus? Sure, it'll take me about 30 seconds. It's pretty easy, actually. They make it way harder than it needs to be. Okay, this is a graph with what we call variable motion, right? Now I've extended the curvy parts here, right? I've extended the curvy parts. Let's talk about the velocity between C and D. I got to quickly wrap up here. Let's talk about the velocity between C and D. I'm going to click on this right here and draw the line. Okay? If I draw a dashed line between C and D, now it's a straight line. And I can find the average velocity between C and D, and it's going to be 4 minus 2, right? All over 6 minus 4, and I get an average velocity between C and D of 1. Now, my question to you is this. If I zoom in a bit here, is the slope right here, let me just put a little, can I do this? Let me see here if I can do this. Okay, so right here is the slope of the, oh no, I want the circle part. Is the graph of the slope part right there equal to 1?
Yeah. No.
The graph of the curve, is it equal to 1 right there? No, not really. What about there? No, not yet. It's only like right about here somewhere that the slope there matches the slope there, right? And then it does what? Up here the slope is actually a little bit steeper. Isn't it steeper there than it is there? Right? So it probably goes from like a slope of about 0.8, 0.85, 0.9, 0.95, 1, 1.05, 1.1, 1.15, and so on, right? But the average between C and D is 1. The average is 1. Okay? What's the overall average of this whole motion? How do I find the overall average for the whole thing? Where do I draw my line between?
Beginning point in there.
Exactly. The overall average is from the beginning to the end, and it would look like that. That would be my average for the whole trip. The whole trip means starting here at 0 and going all the way to the end. And as you can see, that goes from 0 to 7, 7 minus 0, and my time is from 0 to 11 seconds, or 0.64. So the average velocity is 0.64. The average velocity between C and D was 1. At what point on that curvy graph there, if I can get my circle back up, at what point on the original graph, at what point, certainly not there, the slopes are not the same. Where is the slope about 0.64? Somewhere in there? Right? And then it gets steeper and steeper and steeper. And then is there another point?
Well, there.
Somewhere around here, right?
Yeah.
In fact, how would I do it? I'd have to draw a tangent line. I could do this. I could make my line the same as that dashed line, right? Is that line about the same as the dashed line? Almost. Pretty close. Okay? And where is the instantaneous velocity the same? Yeah. Somewhere down there? Right? At that point there, the slope is 0.64. There should probably be another point somewhere down here, right? Just touch it. Somewhere down there. Okay. You need to know the difference between instantaneous velocity and average velocity. You need to know the difference. Average is always between 2 points. Instantaneous velocity is at a single point. And the single point, how do you find it then? Hey, don't. I don't need to hear the binder noise yet. We're almost there, almost done. You would have to actually find points on your tangent line and then do what?
Calculus.
Find the slope, not calculus. Find points on that tangent line and then do the slope. And that's the picture that you need, okay? So, if you were to draw a tangent line at C, you would have to extend your line out, find points. That 3.2 is be about there, and about there somewhere, I think. Right? You find 2 points on that tangent line, and then do what? Find the slope. And this, my friends, is known as the instantaneous velocity. Okay. I know you're going to start doing the binder noise thing right away. Have a look at the Ladybug assignment. You may have made some mistakes. Have a look at it. I may have gone over some today that may help you. Okay, so have a look. We will move on tomorrow. You can put the clickers away.